In this video, we will talk about how to solve equations that are in the form of rational exponents. So these are actually very similar to the radical equations. The only difference is that we're now using fraction exponents instead of radical signs. Remember, those are pretty much the same thing. For example, a to the 1/2, that means the same thing as the square root of a. So here's the main strategy. We have to isolate the rational exponent. So that means isolating this, and those two are pretty much already isolated, and then isolating this right here. We have to isolate the rational exponent, and then we have to raise it to the power of its reciprocal. And here's what I mean by that. If you were asked to solve this equation right here, or actually there's really nothing to solve there. The solution is a equals 729. My question for you would be, what power is a being raised to right here? And the answer is it's being raised to the first power. So we like it when the variables are raised to the first power. If they're not raised to the first power, then what we need to do is essentially make them be raised to the first power, do something that would cause them to be raised to the first. And if you look at this right here, it's being raised to the 3/2. So the question is, what could I put right here? Then when I multiply it by 3/2, it's going to give me a to the first, because that's what we're supposed to do. Remember this property. If you have something here and these two exponents next to each other, we're supposed to multiply those. So what can I multiply 3/2 by that would give me just 1, a to the 1? And the answer is the reciprocal. So the reciprocal of 3/2 is 2/3. And then whatever I do to one side, I have to do the same on the other. So now we have this. Now we have these will cancel. We're just left with a to the first, which is what we wanted. And here we're doing 729 to the 2/3. So the question I have for you is, what root are you taking there, and what power are you raising to? And the answer is this 3 tells you that you're taking the cube root of 729. And the 2 on the top says that after doing that, you need to raise to the second power. You could first square 729, but that's a huge number. That's I think that's 531,441. That's kind of inconvenient to take the cube root of such a large number. So what is the cube root of 729? It's easier to do that first. That turns out to be 9. And then we have to square that. 9 squared is equal to 81. And so there's our answer right there. A is equal to 81. And that's really all we need to do. Alright, see if you can pause the video and try numbers 2 and 3 as well. So the same first step for this one, we need to isolate this thing in the parentheses. If it was just this, if I just said solve that equation right there, that would be easy to solve, because this is being raised to the first power. It's not hard to do when it's to the first power. It is hard to do when it's to the 3/4. So that's what we need to get rid of right now. So I see it being raised to the 3/4. That means in order to make that a first power instead of a 3/4 power, I need to raise it to the 4/3, which is the reciprocal. And the same on the other side. So these will cancel, and we're just left with -3 minus 7n. And then right here, what root are we taking right here? We're taking the cube root. And what power are we raising to? We're raising to this power, to the 4th power. Okay, so this becomes -3 minus 7n. The cube root of 27 is 3. And then 3 to the 4th power is equal to 81. Let's just replace that with 81. And now we can solve it as we normally do. We'll add 3 to both sides. So you get -7n equals 84. And when we divide by -7, we would get n is equal to -12. And that's our answer. Okay, you could plug it in to check, but I can tell you that it will work just fine. Alright, right here, this is number 3. It looks a little bit more complicated, but I want to rewrite this and just ask you if you would know how to solve it if I rewrote it as follows. Suppose that I rewrote this right here as 2194 is equal to 7 plus 3n to the 3/2. Okay, I'm pretty sure you would know how to solve that. Actually, let me make it even simpler. Just make it 3. Make it 3x instead of 3n. If I asked you to solve this, I'm sure you'd tell me what you need to do is subtract 7 from both sides, and then you would have to divide by 3. So let's do the same thing here. Let's subtract 7 from both sides, because the steps are the same. The only difference is I'm taking this whole thing right here and I'm replacing with the letter x, so that we can see how we would solve it if that big parentheses weren't there. Because a lot of people will be confused. They'll say, am I supposed to take this 3 and start distributing? and you can't because it's being raised to that exponent. That's like it's underneath a radical sign. So the use of looking at this equation is to see how would I solve it in a simpler example. So we'll subtract 7, we get 2187 equals this right here. And then, that, by the way, that's a good strategy for any difficult problem, is look at an easier example of the problem and see how you would solve it then. So going back to our easy example, the next thing we would do is we would divide by 3. So we're going to do the same thing right here. Divide by 3, divide by 3. 2187 divided by 3 is 729, and we just saw that number. You'll end up seeing a lot of these numbers repeatedly because those are perfect cubes. So that's usually a hint that we're on the right track, is if we're raising something to the 3 halves, we're going to have to take the cube root at some point. Alright, so now this problem is exactly like problem number 2 up above. We need to cancel out that 3 halves by raising to the reciprocal. And the reciprocal of 3 halves would be 2/3. So we're going to raise this to the 2/3. Those will cancel. And we're just left with this. And then whatever I do to one side, of course, I have to do the same thing on the other. And we already did 729 to the 2/3. That was up above on number 1. Okay, that's taking the cube root of 729, which is 9, and then squaring it. 9 squared was 81. So we did that up above. So we'll add 14 to both sides. Let me just come over here. 81 plus 14 is 95. And then we get negative 5n equals 95. Let's divide by negative 5. And we would end up getting n is equal to negative 19 as our final answer. We could plug it in right here and check, but I can tell you in advance it will definitely work. So that is how we solve rational exponent equations.